These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the annotation. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the annotation. Thank you. Let's make sure we have the derivatives of the trigonometric functions memorized. So there's 4 trig functions we've worked on memorizing, so let's write down those derivatives one more time before the test tomorrow. Well, you got the 4 that we've worked on together. Yeah. That's fine. So those are the 4 I wanted to emphasize and spend the tutoring time on. Now, based on the sample test, there is a chance that you'll also see the cosecant and cotangent. There was 1 or 2 questions about that on the sample exams, but I'm going to continue to let you work on that on your own. So it looks like it would be a good idea to memorize those, but let's focus the tutoring on the 4 that you already know that are most important. Okay, so those 4 that you've written down are correct. Good. So, but the other 2 are probably worth memorizing because there might be 1 or 2 questions about those on the test. I'll go back to my screen for a moment. Okay, make sure that you copy this problem accurately, and then you can tell me how you would solve it and what the answer is.
Okay. Okay, so okay.
Okay, excellent. Very good. So that was a trap. I was trying to trick you into taking the derivative, but you didn't fall into the trap. Because the problem wasn't asking for f prime, it was just asking for f. So it's good that you were careful and actually answered what the question was asking for here. So what does the little number 2 stand for here? Is that an exponent?
Yep.
Yeah, the little number 2 here really is a exponent. All right, I'll write something down on my screen again now. Now, this is something you and I haven't talked about, or we haven't talked about very much. But do you know how to answer this question? Can you get an answer to this?
I believe so. I know that f prime of x would equal 1 over square root of 1 minus x squared, but I'm not sure how to just solve for the function in this scenario.
Okay. So is this question asking us to take a derivative?
No, it's not.
No. Good. So what does the -1 stand for here? Does the -1 stand for an exponent?
It does not.
No, it doesn't. So does this just mean 1 divided by the sine of x?
Yep.
Well, no, it doesn't. That's what it would mean if it was an exponent, right?
Okay.
Right.
Okay,
Now,
okay,
-1
yeah.
exponent means if x to the -1 is 1 divided by x, right? But this -1 is not an exponent. It has a different meaning. As we discussed in a previous session, there's a bad use of notation here. The mathematicians have an abusive notation. They use that -1 means something very different than the 2 in the previous problem. So we have to just get used to this poor notation that the mathematicians have come up with. What does the -1 stand for? Do you know how you would read this function? This is the inverse sine of x. So the -1 means inverse sine of x. Okay. Now, this is not asking us for the derivative, so we just want to know that, see if we can evaluate this. Well, how did you figure out the sine of x? Well, you used your calculator to do that. So basically what I'm asking you is, do you know how to find the inverse sine on your calculator?
Second sine.
Yeah, if you look at the sine button, it says sine -1 right above it, right? Is that -1 on your calculator, is that an exponent?
It's not.
No, not there. It means inverse. So all I wanted to review for this problem was just how to use the calculator to find the function. So let's go ahead and do that.
Okay, so second sine of 3.
Oops. All right. So much for my beautiful example here. It'll probably give you an error, right? It's actually not defined there. All right. Let's do f of 0.7. Sorry about that.
Okay, no
F
problem.
of 0.7.
Okay, so second sine 0.7. Okay, 0.775.
Okay, so let's write down that answer. Okay, so before we start learning, so what are we studying now? We're moving to the section of your textbook that's on inverse trigonometric functions. And before we learn how to take derivatives of those, we just want to learn the basic high school stuff of how to just to evaluate the function itself. And we can do that on our calculator. I'll go back to my screen. So I should have done this. So let's try this problem.
F of -0.2. Okay. Second cosine, -0.2. Okay.
Okay, very good. So we just wanted to review how to do this on the calculator. Good. So those are all correct. Okay, so make sure you copy this problem accurately, and then we can try it on your screen. So let's give this a shot. Now, this is something you and I haven't worked on before, but do you know how to answer this? You might have worked on this on your own. Or if not, we'll go through it together.
Okay, so this one is the different one. This one is 1 plus x squared. Okay.
Okay, good. How did you know that was the answer? Well, apparently you just went ahead and memorized the derivatives here, so that's good. There's a big part of the course that's just about memorization, and this is one of them. So it's good that you've just memorized that derivative. Notice that this is a kind of surprising derivative because even though we started with trigonometry, we got just kind of a rational function with a polynomial in it. So that you might not have predicted that we would go from something that has a trigonometric function to something that has no trigonometric function in it, but that turns out to be the case. How would you read this f of x aloud? How would you read f of x aloud? What does that function say in words?
The slope of the tangent line.
Now remember I was asking you for f of x. That actually doesn't
x.
have anything to do with the slope. So actually what I was going for is not the interpretation. I just wanted to make sure we can read aloud. So f of x was tangent of negative 1x, right? We don't want to confuse
Right.
f of x and f prime. How would you just read that aloud? For example, if I said f of x was sine x, or if I said f of x was sin x, you would read that as f of x is sine of x. So how would we read this aloud?
The f prime of x equals
Well, actually,
1 over...
remember the question was not about f prime. It was about f of x. We have to be very careful not to confuse f of x and f prime of x. Those are two different things.
Okay, so the function of x equals the inverse of tangent x.
The inverse tangent of x. Yeah. So I just wanted to review, what does tangent negative 1 stand for? It stands for inverse tangent. What is an inverse tangent? What does that mean? Sadly, we've got so much to cover tonight. I don't think we'll have time to talk about that. So unfortunately, we're going to be learning these inverse trigonometric functions without really learning what they mean or how they're used. Maybe at some other point in the course, we'll have to come back and learn their meaning. But for the mastery test, all you need to go over is just the mechanics of finding the derivative. So we're just going to treat this as a function without really talking about what the motivation is for being interested in it. But we should at least know how to read that symbol. So that symbol is inverse tangent of x. Okay. So there's three main inverse trigonometric derivatives you might be tested on. So let's write those down. Let's write down the derivative of inverse sine, inverse cosine, and inverse tangent.
Okay, this is 1 over...
Excellent. Remember that a shorter way you could do that would be to do sine negative 1x prime equals 1 over root 1 minus x squared. There's nothing wrong with the way you wrote it, but that would be a way to just summarize it in one line.
Okay.
And you already have the tangent. Good. There's also inverse cotangent, inverse secant, and inverse cosecant, but I think your instructor let you know that those are don't come up very much. I don't think I saw any sample test questions about those. So I think these are the three that we should need to focus on memorizing. So we're just going to memorize these. Looks like you already have them memorized, so that's good. They're a little surprising because we're going from trig to a polynomial, but it turns out that those are the correct derivatives. Okay, I'll go back to my screen for a moment. 1 second. Oops. Okay, let's try this problem.
Okay. So, a function of a function. Okay.
Okay, very good. That's a good approach. Again, if we had time, it would be good to go back and check all these answers on the calculator. That would be good homework, but we won't do that to save time during the tutoring session. So one thing you saw here, what's the most common mistake that people make on a problem like this? Well, a lot of people don't realize they need the chain rule here. A lot of people think the answer is just 1 over 1 plus x squared squared. They don't realize that there's both an outside and an inside function here. That's something I forgot to point out when you were writing down the derivatives a second ago. So all of those derivative formulas that you just wrote down only work when you're taking the inverse trig function of just a single variable. They work for the inverse sine of x, or the inverse sine of y, or the inverse sine of u. But they don't work when you're taking the inverse trig function of a function of variables. So if you were taking the inverse cosine of x squared or the inverse sine of x plus 2, you can't use those formulas anymore. You have to go to the chain rule. But you didn't make that mistake. You did that correctly. You saw there was both an outside and an inside function here. Okay, good. So you can see that we're starting to see a kind of a pattern to the course here. We're applying this a lot the same way we did before. We learned the formulas and now we're applying the chain rule to it. Okay, that was good. I'll go back to my screen.
Okay.
And let's try this one.
Function times a function. One times inverse cosine is just inverse cosine, and then derivative of inverse cosine. Okay. Okay.
Okay, that's good work. That's right. You double checked your work. That's good. So this was an example where we combined inverse trig functions with having to use the product rule, and you did that correctly. That's good. I'll write down another problem. Let's try this one.
Okay. So function times a function. Okay. 3 times second tangent. Oh, wait, no. Yeah, 3 times second tangent 1 plus parentheses 1 divided by 2 times 3 minus 7, 4, negative 4. Okay. Check. 3 times tangent of 1, the inverse tangent of 1, plus 1/2 times negative 4. Okay.
Okay, good. By the way, did you ever check with your instructor on this type of problem? Do you actually have to calculate the answer on the calculator, or will they give you credit if you just show the whole big expression with a 1 plugged in?
Yeah, for this one we have to solve like you were saying.
Okay, good. That would be my instinct anyway. Good. Okay, so notice that was one reason why we did that exercise earlier on making sure we knew how to do inverse trig functions on the calculator, right? In order to get that right, we need to know how to use that second tangent button on your calculator. Okay, how would you interpret your answer?
Okay. So this is f prime of 1. So as the function increases from 1 to 2, thus the value of the function increases by 0.356.
Excellent, good. What is the function that you're talking about?
The function is 3x minus 7 times tangent, well, the inverse tangent of x.
Yeah, 3x minus 7, not times the tangent of x, times the inverse tangent of x. We haven't had time to really explain what the difference is between tangent and inverse tangent, but anyway, they are two different things. Okay, good. And what would be the graphical interpretation? Okay, so as x increases from 1 to 2,
the slope of the tangent line to the function is going to be 0.356.
Okay, that's good, except the first comment you made didn't quite make sense. You don't have to say as x increases from 1 to 2, the slope just is a number. The slope, all we need to say, you're kind of combining the two interpretations together. We could just say that at x equals 1, the slope of the tangent line to the function is 0.356. Okay. All right. So you did that correctly. This was a good combination of the inverse trig derivative and the product rule. So you got that right. I'll go back to my screen. Let's try this problem.
Okay. So yeah, I think there's a faster way to do this, but I'll just stick with the quotient rule. Okay, so plug the inner function back in for u squared, and then the derivative of the inner function by a quotient rule. One plus x squared minus 2x over. Okay.
Okay, good. Well, it's a good thing you went back and double checked, right? Because you did find a mistake. You had left out an exponent. So that's good. It's good that you went back and caught that mistake, because otherwise we'd certainly lose credit for that. I think now we have the correct answer. Okay, this is a challenging problem, but you took your time and you caught your mistake, and it looks to me like that came out correct. I realized after the tutoring session that the student and I had both made a mistake on this problem that we didn't catch during the session. So I'm going to go back now and fix that mistake. So I think here's the work that the student used during the session when they were doing the problem. And like I said, unfortunately, there's a mistake in here. So I suggest that you should now pause the video and see if you can find that mistake on your own. Pause the video and see if you can find the mistake that we made. Well, the mistake was in this line. Notice that here we're taking the derivative of 1. And I guess we made a mistake during the session and we said the derivative of 1 is 1. And then we said 1 times 1 plus x squared is 1 plus x squared, but that's not right. The derivative of 1 is actually 0. And 0 times 1 plus x squared is 0. So this whole term shouldn't be here. The derivative of 1 is 0. 0 times 1 plus x squared is 0. So that term drops out. Then here we have the derivative of 1 plus x squared. That is 2x. So this term was correct. Okay, so now we've fixed that mistake that we made. So the answer that we arrived at during the tutoring session was incorrect, and now this is the correct answer to this problem. So the lesson here is, what's the derivative of a constant? Well, the derivative of a constant is 0. On a hard problem like this, it's probably a good idea to label what we're doing a little bit more. So what was the justification for the first line of your solution? What were you doing in the third line there? What rule did you use to get to there? The chain rule. And let's also write down the justification for the next line. Yeah, that's right. You actually mentioned this aloud. But anyway, it's good to make a note to ourselves so we don't get lost in the middle of the problem. Any idea, how would you go about figuring out this? Let's talk this out in words. How would you go about working out this problem?
Well, we could rewrite the function as x to the negative fourth, and then we could use the n-1 rule, and then...
And that's pretty much it?
That's it.
Good. Okay, that's right. So you could rewrite this as a normal power function, and then you could use the power rule, is basically what you were saying. Good. How would you find the derivative of this?
Same thing, so we could rewrite the function as x to the negative 1, and then our derivative would be negative x to the negative 2.
That's right. Okay. So going back to this problem here, so after you used the chain rule, you had
okay.
You had this, and then you mentioned that there was you might be a simpler approach, and you weren't quite sure what it was. So you ended up using the quotient rule here. Can you think of any way that we could, any other approach we could use to find this inside derivative?
We could bring that to the top, so it could be 1 plus x cubed to the negative 1 power.
1 plus x squared to the negative 1 power. Good.
Okay, sorry.
And we're still, so have we taken the derivative yet?
Nope.
No. So far, so you could rewrite it like this. What would you do now?
Let's see. Now this is chain rule, I think.
You'd have to still use the chain rule again. That's right.
Yeah.
So this is not necessarily better than the way you did before. It's just an alternative approach. The way this is probably the way your instructor would do it. There's nothing wrong with the way you did it, but it is good to know there's an alternative approach. It is going to be important as the class goes on to understand how to rewrite denominators as negative exponents. So like I say, there's nothing wrong with the way you did it, but it's also good to see it this way. So I think what you just noticed here is that if you did it this way, you'd have to do chain rule twice in a row, right? Now we'd have to use the chain rule again. That would be a good homework exercise to try that and make sure you got the same answer both ways. Okay, so like I said, your way was good too, but that's the alternative approach. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the annotation. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the annotation. Thank you.